Hello everyone, welcome to another tutorial series. In this module we're going to be covering a flying enemy AI. So it has a few patrol points, as you'll see here, these little red squares. And as it goes through them, it will smoothly go between them until it sees the player. And once it sees the player, it'll come track us down until it reaches a certain point, stop. And once we get a certain enough distance away, it'll resume its chase. And if it can no longer see us, it will go to the last position it remembers and spin around and eventually go back to the patrolling. So let's get into how to make this one. So pull the other project up here on the other monitor. So in our project, resuming from the last one, we're going to make a new blueprint class. This one's going to be called BP Aggro. And we're also going to need another actor. This is going to be BP Patrol Location. So for the aggro, we actually want to reparent this to a pawn. And for the patrol location, this is fine the way it is. We're also going to go to enum, so we're going to make a new blueprint enumerator here. It's going to be E aggro flying mode. And it's going to have 3 entries. So the first one is going to be patrolling. The second one is going to be aggro. And the third one is going to be looking for player. These represents the 3 modes that the actual AI can be in. And then lastly, the last thing we're going to do here when it comes to adding content is we're going to go to our materials. If we find our material, these are third-person materials, and create a material instance. This one's going to be called red emissive, and we're just going to change its color over to red. Perfect. So for the patrol locations, we can add a box here, or a cube, and set its scale to 0.2. Make sure that it has no collision set, and change its material to the red emissive. Save that off. Then we go over to the aggro pawn and we create another cone here. And likewise, it's going to have the 0.4 scale, and we're going to rotate it 90 degrees on its pitch so it's facing forward. We're also going to apply the red emissive here, and we're going to add 2 things. We're going to add an arrow to see the forward vector of the actual pawn itself, and we're also going to add a floating pawn movement. This time in the floating pawn movement, we're going to change some of these default variables here. So I'm going to leave the max speed at 1200. I'm going to set the acceleration to 300, and we're going to set the deceleration to 0. And this is because of, since we're using timers instead of the tick event, we want to get rid of the deceleration, and it'll also provide much more of like a spline based curvy movement rather than a very snappy type of movement you see when it comes to a lot of other AI systems out there. And the reason we chose to go with the actors rather than the patrol points, with the patrol points rather than the splines, is because if there are sections of a spline that are a bit longer, say for example, I put one of my spline points here, one here, and then I put the next one here, it would traverse this path much faster than it would this path, just because of how splines are set up. So let's get into the actual code behind all this. So the first thing we're going to do is we are going to set up a couple timers, just like the last one. So we'll do set timer by event, copy that over, place it over here, and promote this to variable. and promote this to variable. So this first one is going to be the movement timer, and the second one is going to be the check for player timer. And each of these needs their own tick rate, so we're going to promote both of these to variables, set them both to looping, and we'll rename them. So this one's going to be movement tick, and this second one is going to be check for player tick. Just plug that right on in there. Get rid of the events that you see when you create a new actor, and then we'll create two events. So this one's going to be called movement tick. This should be rate. And this one's going to be check for player. We'll space these out a little bit. Alright, so let's put these in their categories. So we'll have one for movement, and then one for check for player. And we're also going to need to implement the aggro flying mode enumerator that we had earlier, and we'll call this movement mode or flying mode. Compile, save, and we'll throw that in the movement category. So we're going to drag this out and we're going to switch. Now we're going to create 4 functions. We're going to call one patrol, one aggro movement, and we'll call this movement, and then one another one called LFP movement. And we'll also create another event called do movement tick, and on this one we will add 3 variables. So 2 booleans and a vector. The vector will be called location, and then this one will be called do forward movement, and the second boolean will be called do rotation. Perfect. So on our movement tick, what we're going to do is we're going to call all of those events based on its movement mode. So aggro will be aggro movement, and look for player will be LFP movement. Now, let's implement very quickly the movement tick function. So we're going to branch out from here, and we're going to call a sequence, since we have 2 things, and then if I hold B and click, it'll put a branch, and I can do 2 of those, and we'll do 1 for each. Straighten these out here, give it some room, and on our floating pawn movement we're going to add input vector. And then what we're going to do is we're going to get actor forward vector and multiply this by a float. Feed that into the input vector, drag off from true and plug that up, and then lastly we're going to drag out from here and we're going to do select float, and it's going to be the second one under the utilities. And we can also drag this movement mode and give it a different speed based on its movement mode. So we'll right click promote to variable for patrolling, and then we'll right click promote to variable for aggro. Put those both in, and we'll call this aggro move speed, and we'll call this one patrol move speed. Compile, save, And let's give them all some default variables. Let's give everything some default variables. First, let's throw these in their respective categories: patrol and aggro. So movement tick rate is going to be 0.1. Check for player tick is going to be 0.2. If we click on flying mode, it should be default to patrolling. Patrol move speed, we'll put 1. And aggro move speed, we'll do like 1200. Cool. Now it's time to do the rotation. So we're going to get the vector minus the vector, and we're going to get actor location. So that way we have a forward vector towards wherever we want to go. And we're going to normalize it so we can add our own anything to it. But actually in this case we're just going to get the rotation from X. And similar to the last one, we're going to do another rinterp here, rinterp2. This is going to be our target, and our current is going to be get actor rotation. And we're going to plug this into set actor rotation. Delta time, similarly to the last one, is the movement tick rate. Interp speed we're going to promote to a variable. And actually what we can do here is we copy this select and we can plug that in. So this one can be the patrol move speed, patrol rinterp speed. And we can promote this other one to a variable and call this the aggro rinterp speed. And the default variables we're going to give those, values we're going to give those, is going to be, so compile save and we'll get access to it, 30 and 50. That looks great. I think we're all set there. So now what we need to do is we need to get some patrol points. So what we're going to do is we're going to make a new variable called patrol points. This is going to be of type actor. It's going to be instance editable and expose on spawn, and we're going to click the little circle up here and we're going to click array. So we have an array of actors and we're going to throw that into patrol. So when we first start up, we need to make sure that these are valid, right? So we'll create another variable called can patrol. And we'll change its type back to a single variable. And we'll create a new function up here. And we will call this function check can patrol. So for this function, what we want to do is we want to get our patrol points, get the length of the array, check if it's greater than 0. If it is, then we will continue with the rest of this. But if it is not, then we can just set can patrol to false. And if we have no patrol points, then we can't patrol. Next, what we want to do is we want to get our patrol points again, and we want to do a for each loop. And we are going to make a local variable here. You'll see down here local variables. And we're going to set its type to integer. And we'll call this invalid indexes. So for each of these patrol points, we want to go through and we want to check is valid. So that way we don't have to constantly do it every time we move. And we can save a couple instructions and optimize it just a little bit since we're already here. So we're going to get this invalid indexes and we're going to add 1 to it each time it finds one that is not valid. And then once that is done, we can just do get invalid indexes and we can say is it equal to the length of the patrol points. And we'll set it to set can patrol to the result of this. Actually, sorry, not. Because if we can patrol, then there's at least one valid index, so those numbers should not be equal. But if every index is invalid and and all the indexes are equal to the length of the array, then it will be set to false, and we cannot patrol. So next, let's put this can patrol into its proper category, and then we'll create a new function, and we'll say get next patrol location. So we're going to need another regular variable for this, another integer, and this is going to be called patrol index. Put it in its category, and what we're going to do here is we're going to do set. So we'll do select integer here. You can just use the regular one. And we're going to get patrol index, add 1 to it, and we're going to check if it is equal to the length of the patrol point array. And we're going to plug that into B. So what's happening here is if we reach the end of the array, we're going to reset its index back at 0, so we can just loop right over it. And then lastly, what we're going to do is we're going to get our patrol points, to get a copy of a single one, and we're going to plug in this value right here, and we're going to check, is this one valid? And if it is not valid, then we're going to find the next one. So the reason we had to create that initial check if for the patrol points, not only because we don't want to check is valid each time, but also by doing this, say for example we didn't do that check, it would keep checking over and over and over during a single frame and essentially freeze your game. And since it's like an infinite loop, we're just saying, oh, none's valid, okay, find another one. But since we have that check and there's always going to be one valid, it'll loop over until it finds the next one. So if you have 100 patrol points or 100 variables in this array right here, say I add 100 and none of them are valid except for one, it would have to go through one by one to check each one if it's valid. So it is very important to check whether or not you're setting those to be valid. Okay. So we're almost done with the patrol movement. Now we just need to actually incorporate it. So we're going to do another branch here. We're going to see, can we patrol? And if we can, we're going to do a branch. And we're going to get from the patrol index, we're going to get the current one. And we're going to get 2 from here, so we're going to get distance 2, and we'll plug this one to the other actor, and then we'll also get actor location. So for the target, we're going to do this, or self, and we're going to see if this is less than and we'll promote this to a variable, and this is going to be called the acceptance radius. Patrol acceptance radius. So if we're less than the acceptance radius, which I'm going to set to 200, then we're going to get the next patrol point. But if not, then what we're going to do is we're going to call this do movement take. And we're just going to feed in the location, and we're going to check both of these. So now's a good time to start commenting. So this is going to be called movement. This is going to be called patrol. And let's give it a shot. So we'll place in our actor. BP aggro, and we'll put in a few patrol locations. That looks good. And then on our actor here, we can just add 4, and do 1, 2, 3, and 4. So let's check up. Doesn't seem like he's moving. Oh, we forgot one of the most important things. On begin play, we need to check can patrol. Push play, and he should start moving. So he's going to hit this first one right here. Once he gets close enough, within 200 units, then he's going to go to the next one. Going straight for it. Once he gets close to that, then I'll go over here. And likewise. So if you do think he is a little jumpy, what you can do is you can lower that rinterp speed right here. So say I wanted to really slow down, I could do like 5. And you'll see the cost of doing that. So that actually looks really good. But if you go too low, then since his command is to always go forward, whichever way he's facing, you see he curves around it like that. If he takes too long rotating, he would just keep going straight, kind of like this, until he eventually comes back around. So you do want to be careful with how high you set your rinterp speed, how low rather you set your rinterp speed. Alright, so now let's get into the last sections of the tutorial, which is having it follow the player. So on our check for player, we're going to add a new function here, and this is going to be called trace for player. And this one, what we're going to do is we're going to get player character. We're going to get actor location minus vector, get actor location for the actor we're calling from. So we have that vector again. We're going to normalize this. And then we're going to get this arrow. And we're going to get forward vector. And we're going to do what's called a dot product. And this will allow us to see if the actor is facing the other one or not. So what we want to do here is we want to do a greater than. And we'll promote this to a variable. So this dot product will return either -1 to +1. -1 if it's facing in the complete opposite direction of the player, and +1 if it's facing directly at the player, and everything in between. So 0 would be it's at a 90-degree angle to the player, and what we want to do is we want to promote that to a variable, and we want to call this like find player dot. And we'll give it a value of 0.5 or 0.6. So if it has a 45-degree field of view in front of itself, that it would be able to say, okay, we can look for the player here, and we'll do a trace for that. So since traces, if you do a lot of them, say you put like 10 of these guys in a world, they can get pretty heavy. We want to get it out by some simple math, and that kind of makes up for it. And what we'll do here is we'll get the arrow location, get world location, do a line trace for objects, plug this in as the start position, plug that into true, and for the end we're going to plus vector, plug that in, and we're going to yoink this normalize here, and we're going to multiply this by a float. Since this is the direction from the actor to the player, we're going to trace, like we've already determined we're in the field of view, so now we're going to determine whether or not we can see the player. If we hit, like say we hit one of the cubes in the way or something else in the way, this line trace is how we would figure that out. And we're going to call this player trace distance. And we'll set it to, ignore the arrows, we'll set it to 5,000. It's complaining because it needs this object types array, so we're going to make array. and we'll add pretty much everything. Just think about anything that would be, we definitely need pawn as well because we need to find the player, but world static and world dynamic, those are going to be your objects in the world. And if you do play around with like physics bodies or destructibles, maybe even vehicles, you're going to want to add anything that could possibly be in the way or that is gameplay relevant. For draw debug type 2 as well, we're going to do a select down here, and we're going to change this index to a boolean and promote that to a variable. We're going to call this trace debug. And if trace debug is true, then we're going to trace for duration. And this will help us in the future if we need to figure anything out or debug anything. So right off the bat, what we can do is do another branch here. Plug the return value from the trace directly into it. And we need to, if we go back to the front, we click on the first node in the function, we can set up our output variables. So we'll do 2 of them. One's going to be a vector, one's going to be a boolean. This boolean is going to be called found player with a question mark and then location. So off every false, since it's return, we need one everywhere that the code could possibly execute. So both of these falses need to have the return node with found player set to false, and then off of true we're going to break the hit result, and we're going to see if the hit actor is equal to, and we'll do get player character, and we'll just plug that right in. And then what we can do here is just plug that into that and plug the impact point into here. So now we're pretty much almost done with this. So what we just need to do is we need to call this function trace for player. We're going to do a branch here, and we're going to promote this to a variable, and we're going to call this one last saw player location. And we're going to throw everything into its proper categories. So throw those there. Last saw player location is going to be aggro. And we'll call this check for player CFP. So aggro movement down here, this function right here that's not implemented yet. We're going to get actor location. We're going to minus vector, plug in last saw player location this time, get the length, and we're going to check if it is greater than a new variable that we are going to call aggro acceptance radius. Get a branch again, plug that into there, and off this one we're going to do movement tick. So we have the location, which we can actually just plug directly in, and if the length is greater than the acceptance radius, which we are going to set to 400, then we want to do both of the movements. But if it's not, then what we want to do is only do the rotation. So we're going to uncheck this, do forward movement, drag this over here, and we're also going to set its velocity to 0. So that way it stops dead in its tracks. And very similarly, what we're going to do for the look for player movement is we're just going to copy and paste this, plug that in there. And then off of false instead, we're going to also copy this velocity. And we're going to add some new variables. We want 2 integers. One's going to be called looking for player counter. And the other one is going to be called max LFP. And we're going to set max LFP to 50. And what this represents is every time that this is ticked, so every 0.1 second, so 10 times per second, we're going to add to this look for player counter. And if it reaches more than max LFP, which would be 5 seconds since it's 50 times 0.1, then we're going to set it to go back to patrolling. So we're going to get branch here. And we'll set movement mode, flying mode to patrolling. So if it loses this, it'll go back to patrolling. And if it's not, then what we're going to do is add world rotation. And we're going to split this up. And what we want to do is just off of the yaw, which is the, in this case it would be the red one, so we can spin around. What we're going to do is float divided by float. And we're going to get 360 for 360 degrees divided by max LFP. So it'll do a full 360 before going back to patrolling. And the very, very last thing we need to do is set its movement mode here to aggro. And then off of false, we need to do another switch. You could also do equals, and we want to check if we found the player, set it to aggro, but if we lost the player and we were on aggro, then we want to set flying mode to looking for player, and it'll go back into that mode. And we need to also reset this looking for player counter. So just for the sake of this tutorial, and since I already gave you a proper demonstration, we're going to do a trace debug. So I push play. You'll see once I get into range, you'll see that the AI starts looking for me, and it'll start tracking me down. Once it loses my position, it'll get to its acceptance radius to the last point it saw me, spin around, and then go back to patrolling. And then once I'm in its view again, it'll start tracing me. And otherwise it will just keep looking and looking and looking for me. Alright, this has been a little bit longer of a video. I wanted to get into shooting, but I think we'll cover that in the next one. That's going to be a much shorter one. We're going to copy some of the shooting mechanics from Nier Automata, and how like your flying follower, it'll shoot where you're shooting, and then we'll tie that same dot function of the enemy AI to its shooting. So we'll make sure that we can only shoot at the player when it's looking at the player. And lastly, the one thing I wanted to say is that I started a Discord and I started live streaming on Twitch. So if anyone needs more help, you guys feel free to join that. And if you catch me while I'm live streaming, feel free to ask a question, and I will definitely be willing to help. Have a good one, and thank you for watching. Bye-bye.